Okay, now let's continue with this clipper circuit. Now, what we were discussing, that is a positive clipper circuit. Now, let's see what happens during the negative clipper circuit. Then we'll have the circuit connection, same input, which is your sinusoidal sine wave with your 10 volts peak. With your 10 volts peak, your resistor, which is your R limiter, then your diode. But now the connection of the diode is going to be different from how we connected it previously. Now you will see that now your diode is connected in this manner. Now your diode is connected in this manner. That is the negative, that is the positive. Then you have your resistor there, which is your output resistor. That is your RL. That is your 10 kilo ohm resistor. That is your 100 kilo ohm resistor. Your 10 kilo ohm resistor, your 100 kilo ohm resistor. Now with the diode, then we say this diode, reference D1. Let's say this is your silicon diode. Let's say that is your silicon diode. Now, then I'm going to say we need to work with this component here. We need to work with this component here. Now, if we look at the signal, which means your signal, it is going to be a sinusoidal signal of your input, sinusoidal signal of your input. There, then you have got your peak, which is 10 volts, and then you have got your minus 10 volts. Now, what will happen during the positive cycle? What will happen during the positive cycle? Now, you will see that during the positive cycle, you will have current flowing in that direction there. Positive, negative, you will have current flowing in that direction there. If current is flowing in this direction, continue flowing, but when it gets there, it sees a junction. But now within this junction, it will flow that direction and also flow that direction. But now what's going to happen? You will see that the connection of this component with respect to the connection of your energizer there, with the connection of this component with respect to the connection of the energizer there, it will force this component to be on a reverse bias mode, which means it's not going to allow current to flow. And if it doesn't allow current to flow, which means this component, it is at an open switch. And if it's an open switch, then the current will continuously flow within that direction there. If the current continuously flowing within that direction, if I want to measure my output, with the continuous current flow, because that's diode, it is not switched off, then my output, my V out will be according to Kirchhoff on a series circuit. Then it is going to be your V out will be your 100 kilo ohm divided by your 100 kilo ohm plus your 10 kilo ohm multiplied by your 10 volts, which means I'm going to use the voltage divider rule. Now, your output in this manner, it is going to be the replica of your input. Your output, it is going to be a replica of your input, whereby by just a small margin of what? By the small margin of your magnitude, which means I'm going to have the input positively, how I measure it on the output without tampering with this, depending on what will be the magnitude there, which means you're going to use your calculator to find what is the magnitude there. Then here,
Ma'am, the screen has disappeared.
Testing 1 2 testing 1 2.
What is happening now?
Yes, I just saw it now.
Oh, okay.
I'm going, let me switch it on.
Okay, but I don't see you. Did you leave the meeting?
No, I didn't. The phone just switched off. So I'm trying to switch it on. I don't know
Okay.
what happened.
Okay, I don't see you on the list, so maybe you must rejoin, okay?
Yeah, I'm going to rejoin now.
Okay, dankie.
Okay. Now, you will see that that is during when this component has switched off. Now, when this component switches off, which means the current will continuously flowing throughout as a series circuit, not considering this, then your V out is going to be a V out of 100K divided by 100K plus 10K multiplied by 10. Now, that is the replica, or it's going to be a replica of the input with just a small margin. Then you will see that from how the signal it is energizing with how the shape is up until you get back to zero. But now, that is during the positive cycle, which means during the positive cycle, this component doesn't switch off. But now, when your cycle continues, you will see that now you are looking at this at the negative cycle. Let me use a different marker. You are looking at this at a negative cycle, which means now your polarity is going to change, which means when your polarity changes, then here you will have more positive, more negative, more positive there, which means now your current, it is moving within that direction there. Your current, it is moving within that direction there. Now, if you have got current moving within that direction, you will see that here you will have more positive there. Then the positive with respect to how your current is flowing and your diode, then it's going to force your diode to go into a forward bias mode. Now, when the diode goes into a forward bias mode, which means now the internal voltage has been established or your barrier potential has been established, the switch has been closed, which means now you are allowing the current to flow. Because this component and that component are parallel to each other, this component and that component are parallel to each other, which means whatever that I'm going to measure here during the process whereby this component is a forward bias, because it's silicon, which means it's going to be what? It's going to be your 0.7 volt. But now it's 0.7 volts when it's 0.7 volts when you will see that it's 0.7 volts when your cycle is on the negative side. When your cycle is on the negative side, which means it's going to be minus 0.7 volts, because you switched on the diode during the negative cycle. You switched on the diode during the negative cycle, which means it's going to be minus 0.7 volts, which means when I measure the V out, which means now my V out, it is going to be a V out of minus 0.7 volt. A V out of minus 0.7 volt, which means I am going to do what? Whatever that is going to happen within the input, whatever that is going to happen within the input, your input and the output, it is going to be only this portion there of minus 0.7 volt, which means with the continuation of your graph, when you switch on this component, you will only measure a 0.7 volt. Let's say if your magnitude of 0.7 it is there, then that is where your graph will start. So that is where your graph will stop at minus 0.7 volt. Now, I have eliminated the remaining of your input. I have eliminated the remaining of your input to a point whereby I only needed a point where it switches on the diode there, which is a minus 0.7 volt. Now, this type of circuit, with respect to how you have interpreted your input and the output, it becomes a negative clipper circuit. It becomes a negative clipper circuit. It clips off a negative cycle, but it allows the positive cycle to go through. It clips out a negative cycle, it allows the positive cycle to go through. But when it clips out the negative cycle, it clips out all the portion. It clips out the portion that we didn't need in terms of what is on the output there. But now, if I say it's not only minus 0.7 or the 0.7 volt, it is too small, which means I need to go and bias that output. When I bias this output, then I will say, let me connect a bias voltage there. Let me connect a bias voltage there. When I connect a bias voltage, which means now I'm going to say, within my output, I will connect my source in this manner. I will connect, let me use a different color, sorry. Let me just use a different color. From the blue, green, red. Then I will say, this is how I am biasing my output. Positive, negative. That is how I am biasing my output. Then here I say I am biasing the output by 3 volts. I am biasing the output by 3 volts, which means if I bias the output by 3 volts, which means my output, now my output will be an output of, I will say, this one, no, sorry. I will say, now my output, it is going to be an output of V out will be given by, you will see that during the negative cycle, I have forward biased this component to be what? To be minus 0.7. So which means it's going to be minus 0.7 minus 0.7 minus V bias, which means it's going to be minus 0.7 minus 3, which is minus 3.7 volt. Minus 3.7 volt. When I look at the signal at the output, which means my signal at the output, because I am forwarding bias, so I am forward biasing this component during the negative cycle, and which means I need to tamper with the negative cycle, the bias cycle. Then I will say I will tamper with the bias cycle when it is at what? When it is at minus 3.7 volt. Then that is where my output will be. Now, within this, during the negative cycle, that is where you are going to clip off your signal. That is where you're going to clip off your signal. Now, that is another way of limiting this diode in terms of a diode limiter circuit. Or I will say, I need this voltage or this voltage. Now it is connected in this manner. This voltage, now it is connected in this manner, whereby this is positive and that is negative. That is positive and that is negative. Now, if it is connected in this manner, if it is connected in this manner, then I will go and say, when it is connected in this manner, my output, it is going to be an output of V out is equals to minus 0.7 plus V bias. Minus 0.7 plus V bias, which is equals to minus 0.7 plus 3, which is 2.3 volts. It is a positive 2.3 volts. You will see that with this positive 2.3 volts, with these positive 2.3 volts, when we bias this during the negative cycle, which means we eliminated, we clipped off the entire bias signal, and we even introduced what we didn't bias with, which is the positive cycle. That is how the signal must look like. We eliminate everything that we bias with, including the portion of what we didn't bias with, which means my signal, or when I look at my signal, now I am looking at my signal with respect to, then I'll say everything that I bias with up until I get to a point of 2.3 volts, which means my signal, it is a signal that is going to be allowed to go into or to be at the output. That is your signal there. Which means everything that I bias with up until 2.3, I need to clip it off or I need to eliminate it. Then the remaining, you will see that it is just a portion of what I didn't bias with. Now that it is a positive, negative clipper circuit. Screenshot this.
Okay. You can continue.
Stop recording. Stop recording.